to streaming settings. You see two fields, URL so that will copy online. Doing that, already connecting whatever that's going in there, you have to share it to YouTube. YouTube is the source. So like you start to connect. You understand? Actually, this is the source. This is the source. This one is the source. This is the source. So YouTube is pushing it to the internet. So that is not streaming. It's pushing it, forcing it into the internet. That's not that is server. I have to do that. So we're connecting the server. Look at the truth. While the event is going on, you will come to YouTube and check how it is. But what you are seeing is what people are saying. The two things you check is the sound. I think it's really good. The two things you check is the sound and the quality of it. If anything you have to do with the workshop, what you're doing. Hello, sir. And that's what I'm saying. We need to see the future. It's automatic. I should check his name. I will see so. Sound, YouTube sound. Is this in? Because now we say if you freeze it, you should go freeze it. You should make it there, slice it there. Yeah. Yes.
Just give them your flash. See your flash.
Make another copy down. No, wait, wait.
I people don't play this song. I people don't play this song.
Thank you.
Very good.
From here to search for that.
That was actually. So you can disclose and go
Welcome to the International Space Station. Thank you. I think that's all the good before. me, but when you're talking to Sarah and Julie, you can say, things that have to do with what you're doing. I want to know about your day-to-day. Like, take me through like an average day for you. You have your own room, you get up, what do? Do you have a shower? Do you have a chef? What goes on up there?
We get up in the morning, brush our teeth, eat breakfast just like everybody else. Except that everything we do, we're weightless, and all the things we're doing it with are weightless as well. So you start off with that teeth brushing thing, and I have to say, spitting, that's going to be a problem. So we swallow our toothpaste, and the day goes weightless from there.
What is your average work day? Is it like a real 8-hour day, or I know what do you guys do? You sit around looking out the windows, and what do you guys do? This is what I want to know.
Seriously, we live to look out the windows because it is simply amazing to look out. And, every day is different looking down at the earth. It depends on the weather, it depends on the lighting. I'm learning geography hand over foot. And so we live to look out the window, but I will say that most of our work is inside, here in the space station. I'm in the Japanese part of the space station. It's the module that they built for experiments. We have a European module, we have a Russian section, United States section, the Canadians built the arm. It's a big, big international venture. And every day, actually the day begins the night before, because I look at the schedule, see what I'm going to do, and I study up. And just try to understand what experiments I'm going to do. And I actually showed you one of them. One of them is coming right at me right now. So before I show you this, let me just show you something else. Oops. Wait, it's going to come back to me, okay? I want to show you why we do these experiments. And that is because this is a bag of water, okay? And I'm squeezing, let's see. So it's a brand new bag of water, and so my straw is a little crimped there. I'm going to come a little closer, and you can see this giant blob of water. And we're getting to see in space, what do liquids really, really want to do?
Wow, that is amazing. That is amazing. So, I'm curious, because I know you have kids at home. How do you stay close to your kids? Amazing. Yeah. I'm just curious how you stay close to your kids while you're in space.
Well, one of the ways that we stay close is I try to keep him really interested in what I'm doing, and I'm shaking up our fluids experiments so you can kind of see, what a real experiment looks like, and not just playing with our water drops, but understanding how fluids behave in space. Well, it has to do with everything we do at home. And everything that we wear, everything that is in our house that is made with the process of something flowing through a pipe, we need to understand what liquids do. And this experiment actually shows us how to design fuel tanks for satellites. And you think, well, gee, why would I care? Everybody uses a cell phone, electronic devices, communication, military defense, you name it. And it all comes from things like this. When we talk about trying to keep my son interested, another way I do that is actually to bring one of his things with me up to space. He's a big fan, and so am I, of Calvin Hobbes. And so I brought a little Hobbes up in space with me, and I bring Hobbes to do experiments, and I take pictures and send them down to the ground so he understands what I'm doing every day. And I did that while I was training for this mission as well.
That's so cool. So, Katie, since you've been in space, what extra daddy duties has your husband had to take on since you're there on a 6-month mission?
Well, You know, I think a lot, and I really thank him for doing all of that. And you know, I would have to say it's hard for me to let some of that go. You know, everything's not going to be done maybe the way that you would do it, and yet I know my son is in great hands. He's just a super dad. I think it's hard for any parent to be a parent alone. I know that because my husband and I both commute, we have a commuting marriage, we're both single parents in a certain way. And so I think it's really hard for him just because there's nobody else to help, really.
On a somber note, okay, hang on one sec. Is the brother-in-law to Congresswoman Gabrielle Giffords. What has it been like at the International Space Station since the Tucson shooting?
You know, it's hard to be far away when things are happening down on Earth, and I can't speak for Scott, but I think something like the tragedy in Tucson, at least for me, it makes me think how precious all my relationships are, and it just made me want to call everybody that I love and just make sure that they knew that I cared about them. And up here, I think that we have a serious job to do, and we're intent on doing our jobs, and we try not to let things get in the way. And at the same time, there's a value in just thinking about what's going on and trying to come to terms with it.
Yeah, I'm curious, does it get lonely in space?
Well, I was very excited about this interview just because I won't necessarily say it's lonely up here, but there are not a lot of other women. And so actually the thought of sort of having coffee with you guys was really appealing to me. In fact, I brought mine. I'm serious. There's something nice about girlfriends. There's something nice about sitting around with your girlfriends and saying hello.
Yeah, I love that. I'm curious how you also prepare to leave for 6 months. That's such a long trip.
Well, I did my best. I know I've left a lot of holes. I'm still writing back and forth with my husband and making sure he understands how to get my W-2 and all those kinds of, administrative things. My son had known for a couple years that I'd be going to the space station, and I tried to make it really clear when it would happen. It took several years to train. I traveled to Japan, to Europe, to Russia, and around the U.S., training for really almost 3 years to get ready for the mission, and that actually worse in a way than being up here. And they like to say that when I'm up here, at least they know where I am, and in fact they have an application, or a computer program that they look at, and they know exactly where I am, and they go, oh, you're going over Australia. So it's pretty fun to be up here now where they know where I am.
What research are you doing in space that you're most excited about?
On a day-to-day basis, I love to do the things that I actually get to touch and move, like the experiment that you saw with the bubbles just now. But some of them aren't as tangible. We're doing some research in osteoporosis, which I think is fascinating and valuable. Basically, I'm an experiment, and because we lose bone mass up here, because we don't walk around on our legs, we lose bone at about 10 times the rate of a 70-year-old osteoporotic woman. And so, because I don't have some of the potential complications that somebody who's 70 might, I'm sort of a clean medical specimen to do some experiments. And so I'm taking some of those drugs, and we're looking at how my bone mass is changing. And we looked at it before I left, while I'm up here, and also when I get home. And it'll help us understand a lot about how osteoporosis, the mechanism of osteoporosis, which certainly affects millions of people down on the earth.
Do the health implications of that scare you?
I won't wouldn't say they scare me, but I take them very, very seriously in that we exercise, about almost 2 hours a day, which I'll say I'm not disciplined enough to do down on the earth. But I do it up here because the implications of not exercising are really having a tremendous amount of bone loss. And I have a 10-year-old and I figure I still have a lot of running around to do when I get home.
Katie, I wanted to ask you, other than your family, your son, as a woman, what do you miss the most?
I'm actually so excited about being here and just living in this environment and discovering new things every day in terms of what's delightful about just being here, about moving back and forth. It's just really such a neat place. I don't actually miss anything yet. I certainly miss my family quite a bit, but at the same time, it's not as if I wish to be there. I'm really happy to be here.
Katie, you mentioned that you exercise 2 hours a day, but being that you have no gravity, how do you exercise in space?
It's a great question, and we have a weightlifting machine which works on the principle of vacuum. Like I'm not really lifting weights, but I'm pulling against something that's pulling on a vacuum, and so it's really hard. Like when you're trying to get a lid off a jar that's got vacuum line, it's harder than if there wasn't a vacuum, or when you're pulling against something. So that we do weightlifting, and I'll do it's like a gym. We have a bar, go up and down, and you use my legs. I can do sit-ups, all these arm weights. We have a treadmill that I wear a harness, and it holds me down on the treadmill. And I have to say that it was really interesting after a few days of not exercising, floating around up here. It was fascinating to suddenly be on the treadmill, standing on your feet. And I thought, wow, standing, that's interesting.
What's the first thing you want to do when you eventually do get home back to your family?
Well, I'm assuming a shower will be like right in there. I mean, I'm actually clean up here. My hair is clean, and we take sponge baths literally, and so you're clean. But there's just nothing about like being, actually in a shower. I think, just being on the earth and walking around on your feet, and I think smelling. And smelling, just the garden and outside and the street and cars, and that kind of sense is a little missing up here. And even just listening to noises that aren't just the hum of the space station and feeling the wind. I'm looking forward to maybe being on a beach and feeling the wind and looking at the ocean.
As we get ready to say goodbye, is there any message you'd like to send out to your 10-year-old son or your husband, your family?
Well, I miss them so much, and I appreciate, it's a lot of work for them, for me to be gone, and I'm just hoping that while I'm up here, the things that I'm doing end up being worth it, and I actually just really think that they will be. What we do here in space somehow says to kids, wow, don't you want to be an astronaut? Don't you think you could do this? Somehow they look at us and they think they could do this, and they're right. And it inspires them to study hard in school and learn the math and science that they need to be part of the future, because they are the future. So it's a long time to be away from family. It's actually a magical place to spend that time in, and I think that the payoff is very big. It's nice to be with you guys today.
Katie Coleman, thank you so much for joining us. We wish you the best of luck up there in space. Keep doing the good work you're doing. Take good care. We'll be right back.
Thank you. Thanks for inviting me.
Station, this is Houston ECR. Thank you. That concludes the event.
Okay, thanks. Thank you. Nice to hear from you guys. Thank you. The TOC station, we are now resuming operational audio communication. Station, this is Houston. Are you ready for the event on MTC?
On MPC, I'm ready as well.
CBS, the TOC. This is Mission Control Houston. Please call station for a voice check. Station for a voice check. Station, this is the TOC. How do
Circles the planet 16 times a day, 350 kilometers apart from planets. The International Space Station is the largest man-made object in the sky and is home to a crew of 10 astronauts. They are carrying out experiments to investigate how life might be lived on the planet. Such work may one day allow us to colonize the moon or even Mars. 4 landmark spacecraft lie behind the success of the International Space Station. At the heart of each structure lies a major technological breakthrough that allowed engineers to build bigger spaceships. One by one, traveling up the scale, we'll reveal the stories behind these incredible machines. Find ingenious leaps forward that enable space stations to grow from big to bigger into the world's biggest.
Go for main engine start. 7, 6, main engine ignition. 4, 3, 2, 0, and liftoff of Space Shuttle Atlantis as Columbus sets sail on voyage of science to the space station.
February 2008, Space Shuttle Atlantis begins a 13-day mission to deliver the latest components to the continually evolving International Space Station.
Kennedy Space Center traveling 2,000 miles an hour.
For the past 11 years, astronauts have been piecing together the structure in space. By the time it's finished, it will consist of 14 modules, including science laboratories and living quarters, and will weigh 400 tons.
Located to go.
At a cost of $100 billion, it is the most expensive and challenging construction project ever undertaken. To understand how it became possible to build something so ambitious, we must travel back in time. Our story begins at the height of the Cold War. To build the world's first space station, Salyut, Soviet engineers must first conquer the pull of gravity. June 1969, America beats the Soviet Union in the race to put a man on the moon.
Go ahead, Mr. President. This is Houston House.
Hello, Neil and Buzz. This certainly has to be the
They want to put a man in space for longer than ever before. Scientists don't know how the human body will cope over time in this extreme environment. So they decide to put a laboratory in space to find out. Salyut will hold a crew of 3 cosmonauts. The pressurized compartments will have a control room and living quarters. The plan is for the cosmonauts to spend 3 weeks there. But to stay in orbit that long, Salyut must travel at 28,000 kilometers per hour for the duration of the mission. Astronaut Leroy Chow, veteran of 4 space station missions, knows the danger of taking your foot off the gas.
If you're not going fast enough and you go up into space, you're just going to fall right back down. So you've got to get into what we know as orbital velocity, and in that way, the force due to acceleration is going to be exactly balancing the gravitational pull. When those forces are equal, then the object will stay that distance from the Earth or whatever object it's orbiting.
To reach orbital velocity, 28,000 kilometers per hour, Russians strap Salyut to a Proton rocket. Once the rocket is in orbit and Salyut is released, there should be nothing to stop it maintaining its speed. Space is a vacuum. There is no air resistance to slow it down. But unfortunately, this vacuum is not completely empty.
Well, in principle, if you didn't have any friction at all, then you would, once in orbit, you would stay. In the case of the Earth, we have an atmosphere of air, of course, and so even at an altitude of several hundred miles, there's still some air molecules up there.
Even molecules of air hitting Salyut are enough to create drag and slow the spacecraft down. If the speed drops below orbital velocity, gravity will pull the craft back to the Earth. To disastrous effect.
So periodically, the space station and other spacecraft need to be reboosted by lighting rocket engines and moving your orbit up higher again in order to counteract that effect of the drag.
But using a rocket to boost Salyut is risky. They go off with a bang and an uncontained blast could send Salyut careering into deep space. Engineers need a rocket they can keep in check. The answer comes from an unexpected place. During the Korean War, the US Army wants to move their soldiers quickly around the battlefield. Engineers come up with a gizmo straight out of Dan Dare. A rocket. A rocket man can hover because his jet is powered by a chemical reaction which he can easily control. Chemist Andrew Shidlow demonstrates how to generate thrust from a simple chemical reaction.
When hydrogen peroxide decomposes, it releases oxygen and water in the form of steam. As I press the syringe like this, a small amount goes in and out comes a puff of steam. Another small squirt, another puff of steam. Now this is controllability. It's the addition of a precise amount of hydrogen peroxide, immediate response, giving off a small amount of steam and oxygen.
The Soviets fit chemical motors similar to those pioneered on the rocket pad to their space station. These allow the cosmonauts to give their ship a controlled burst of power to boost its speed and send it back into orbit. This way, the crew managed to circle the Earth for 23 days, a new world record. It's day 3 of the shuttle's mission to deliver a new module to the International Space Station. Even after it is docked, the shuttle may be required to perform another crucial task. The International Space Station does not use its own thrusters to boost it back up to orbital velocity. Instead, it uses thrusters on a docked craft, such as the shuttle. The space station also has to constantly correct its position to keep its solar panels facing the sun. The panels provide all its power. To make these fine adjustments, astronauts rely not on rocket power, but on this, a gyroscope. Space scientist Kevin Fong demonstrates how a spinning wheel can move a space station.
This is a gyroscope. It's very crude example of the sort of thing they have on space stations now. Like all gyroscopes, once it's up and spinning, it wants to stay where it is. And if you imagine that this plate here is the frictionless, weightless environment of space, if you can, and we get on top of it. If I turn the wheel, it steers me. And if I turn it back the other way and don't fall off, it turns me back again. And that is a very crude demonstration of how control moment gyroscopes steer the space station.
Engineers fit the International Space Station with 4 gyroscopes. As engineers on the ground adjust the tilt of these spinning wheels, they exert a force on the space station which makes it move. The gyroscopes make constant tiny adjustments to ensure the craft's solar panels always face the sun, giving the crew the power they need to carry out their experiments. Astronaut Mike Flink has been on board the space station for 100 days. It's his second run.
So again, excuse our mess. We're in the middle of building a lot of things in my work area. It's a little bit cluttered right now. But this is kind of my desk. It doesn't sit out horizontally, but it has everything I need on it. There's my crewmate, Yuri Lachikov, exercising on the treadmill. Oh my goodness, it's beautiful out there.
Back in 1971, thrusters keep Salyut in orbit for 23 days. The Americans aim to beat that record with an enormous laboratory in space. But first, they must devise a way for their lab to stay in touch with Earth. In the late 1960s, NASA scientists plan a series of unique experiments to be conducted in space. Their laboratory will be a 100-ton space station called Skylab. 3 astronauts will be their human guinea pigs. The scientists want to investigate the tremendous toll that living in zero gravity takes on the human body. They will monitor their experiments from Earth via a communications link. Spending time in space can leave astronauts without the muscle power to stand up when they return to Earth.
Space is a uniquely hostile environment, but one of the things that makes it very challenging is the weightlessness. There's lots of systems in your body that are dependent upon gravity, just the normal upkeep, your muscles and bones, but also your heart, which is essentially a muscle pump.
Without the constant force of Earth's gravity to work against, muscles like the heart begin to waste away. And the longer the human body stays in space, the more muscle power it loses. Scientists must overcome this problem for humans to live on planets where the pull of gravity is less than on Earth. The success of the Skylab mission relies on scientists being able to monitor the astronauts' vital signs from Earth. But there's a problem. Houston plans to use radio waves to communicate with Skylab. But radio waves can only travel in straight lines. It takes Skylab 90 minutes to orbit Earth. So this gives the scientists on the ground a narrow window of just 6 minutes to monitor the crew as they fly over Houston. Not long enough to collect the data they need. So NASA establishes 11 additional ground stations around the globe to assist Houston. That still leaves large areas of ocean with no receivers. So they fix up to the deck of the ship to try to track the space station as it flies over the sea. But that's a lot of ocean for one ship to cover. It's impossible for any ship to travel fast enough to keep up with Skylab. NASA needs radio receivers that are more mobile, so they fit into aircraft. Michael Kiley was one of the pilots assigned to fly these special planes.
Because of the capabilities of the aircraft, we can position these anywhere in the world based on the orbit of the spacecraft, and it provides real-time, continuous, full-time communications with the astronauts.
A 2-meter radio receiver dish is housed in the nose of the aircraft. Electric motors enable the dish to move around so it can aim at any point in the sky. As the space station passes overhead, an operator inside the aircraft can adjust the angle of the dish to pick up Skylab's radio signal. As Skylab passes out of range of one aircraft, another takes over. It takes a fleet of 8 aircraft flying around the globe to maintain unbroken contact with Skylab's crew. Flying these aircraft requires great skill.
You have to be in an excellent position for the spacecraft come over the horizon with the antenna and the airplane pointed towards where the spacecraft was coming up. Track the spacecraft for as long as you could to get the maximum amount of data relayed back to Houston.
Thanks to pilots like Michael Kiley, the Earthbound experts are able to keep a constant check of their subjects in space. The scientists try to strengthen wasted muscle by getting the astronauts to exercise against the resistance of elastic ropes. They give underused hearts a workout by cocooning crew members in a machine that simulates the gravity of Earth. After enduring such trials for 84 days, the Skylab crew proves that the human body now has a fighting chance to survive without gravity. Today on the International Space Station, scientists have worked out that astronauts need to exercise for precisely 2.5 hours each day to keep their muscles healthy. But in this orbiting laboratory, the astronauts themselves are no longer the prime focus of scientific experiments. The astronauts are also investigating how crops might be grown and how animals might be bred in a gravity-free environment. As with Skylab, specialists on the ground keep in regular contact with the astronauts. Today they communicate via satellite rather than aircraft. 9 satellites circle the globe thousands of kilometers above the space station. They are locked in orbit at fixed points around the Earth's equator. Together, the satellites give mission control almost uninterrupted contact with the space station as it orbits below. When the space station transmits a signal, the nearest satellite picks it up and relays it to Earth, where it is beamed to mission control in Houston.
Lucy, that's not a problem. Thanks for the heads up.
Back in 1973, a fleet of aircraft allowed the American Skylab to stay in touch with ground control. But to make a bigger space station, it would require the marriage of 2 sworn enemies and the union of 2 incompatible spacecraft. In 1975, the United States and the Soviet Union made an announcement that shakes the world. They will pool their resources to create a single space station. This joint effort will be a symbol of the thawing of the Cold War and bring an end to the tensions of the space race. Here's the plan. The Soviet Union will launch a Soyuz spaceship from Baikonur Cosmodrome in Kazakhstan. Simultaneously, the USA will launch an Apollo spaceship from Cape Canaveral. Both craft will dock in orbit 220 kilometers above the Earth. Here, the American astronauts will meet the Soviet cosmonauts, and together they will conduct the first ever international.
Hello. Hello. Please, we're about to start now. I'd like to apologize for keeping everyone waiting. We're just trying to take care of some logistics that was beyond our control already. But now we thank God that we are back to the program. Please, if you check our program, it is number one of first introduction of guests. First and foremost, we would like to welcome our executive governor, the executive governor of Edo State, Mr. Godwin Obaseki, who is represented by Mr. Ike Osayande. Please, you're welcome, sir. He's the chairman of this occasion. We also like to welcome the Vice Chancellor, Professor FFO Olumese, who is being represented by the DVC Academy, Professor Iliogwe. Welcome, sir. The VC also double as the chief host, while Professor Babatunde Rabiu, who is the digital director of the Center for Atmospheric Research, who is also the host, is also present here with us. Welcome, sir. The keynote address will be delivered by our old Papa. I know everybody have already seen that we have the oldest man in our midst, who was also the former Minister of Science and Technology. He's also here with us, Professor Emmanuel Momo. Welcome, Papa. We also welcome Dr. Mrs. Evelyn Omolabi Idiodi, the librarian, the university librarian. Welcome, ma'am. We also have our own respected and ever answering to children father, no other person than Senator R.S. Owe, who is also physically present with us. Welcome, sir. We also have the royal father of the day, His Royal Highness Idoria Singh, who is ably represented by Chief J.O. Ajayi. Welcome, sir. We have some selected secondary schools who you see very well. You find out that they are here with different uniform, and we welcome all of you. Please, can we jump our hands together for all our secondary school presence? We have Federal University of Petroleum Resources, FUPRE, from Efurum Delta State. You are welcome. Please, can you just wait there? The FUPRE. You're welcome. We also like to welcome Igbenedion University. Please, you also wave your hands. You're welcome. You're welcome. Please, we also welcome the staff of the senior staff and all the general staff of Center for Atmospheric Research. We have the deputy director. Is also here, Dr. Oga. He's present here with us. We also have Mr. Najib Yusuf, who is also in charge of research and development of the agency. Is here with us. We also have our mama, Mrs. Momo, is also physically present here with us. Mama is here. And also we also have Dr. Ehigiato, who is also representing the DVC admin, is also here present here with us. The HOD of Geoinformatics. Please, we also welcome the CMD of UBTH. We also welcome here the representative. Okay, you are welcome, sir. Please, I think if we want to continue to acclimatize the individual present, we might not leave here today. Please, if you know you have not been recognized, you are recognized. Please, let's jam our hands together for anonymous recognition. Thank you very much, sir. Please, we'll go straight to the national anthem. So we'll honor our nation. Please, may we all stand. At the count of 3, we'll sing it together. 1, 2, 3. Arise, O compatriots, Nigeria following, to serve our father's land, with love and strength and faith. Please, as we all remain standing, we'll take the second stanza as our opening prayer. Please, let's read it together. O God of creation, direct our noble course, guide our leaders right, help our youth the truth to know, in love and honesty to grow, and living just and true. Great lofty heights attain, to build a nation where peace and justice shall reign. Amen. Thank you very much. Please may we all sit. Please, the time we have now, we are going to try as much as possible to summarize and get out also having the objective in mind, get out the information across to all of us. Please, let's pay attention to everything that's going to be happening now. At this juncture, I would like to welcome the chairman of this occasion, who is really represented by Mr. Ike Sayende. Please to come and give us a word from this.
Good afternoon. Please allow me to stand on all existing protocols for expediency. I am glad to be here representing our state governor. This space is infinite. Man is complete space, so we should not put limits on the infinite. That's for the children. Your life should be infinite. What you attain, what you achieve, what you want and aspire for should always be infinite. No limits. I am delighted to attend today's event on Space Earth Environmental Research Laboratory. The Executive Governor of Edo State, Mr. Godwin Obaseki, thanks the Space Earth Environmental Laboratory of the University of Benin, as well as the authorities of the university for organizing and facilitating this event. Thank you. As you may be aware, environmental governance for sustainable development is one of the major cardinal programs of his government. Since Mr. Obaseki assumed office in November last year, the Strategic Planning Unit of Edo State Government has organized several workshops on the environment and other related matters of environmental sustainability. So the theme of the outreach and its objectives are in consonance with his focus on environmental sustainability. The environment, as you know, is a big issue that we can look at from different angles. Environment is the earth. It is water, air, and space, in which people, animals, and plants live, and in which are located the natural endowments that impinge on our very existence. Beyond this, environment also denotes some natural phenomena and conditions resulting from the dynamics of the ecosystem and the use and abuse of nature, such as greenhouse gas emission, environmental pollution, flooding, refuse generation and dispersal, exploratory activities, depletion of the ozone layer, droughts, heat waves, storms, snowfall, among others. A quote from Albert Einstein states, "The environment is everything that isn't me." Space exploration, initiated first by the Russians and shortly after by the Americans in the 50s, is a huge area for research. Space and its dynamics impinge on our existence. The sun, moon, stars, and many planetary bodies are in space, and so the many remote activities go on there. So how do these affect the planet Earth, and how can we use them to improve existence? This is one of the main concerns of space research. Since the commencement of space research, a lot of discoveries have been made in the area. Recently, Earth-like Keplers were discovered by American astronauts in space. However, Africa in general and Nigeria in particular are lagging behind in space research. So efforts such as the one of your lab in Winnipeg should be supported to bring Nigeria up to speed in space research so we can get the attendant benefits. Mr. Gordon University's government is willing to collaborate with the Space Earth Environment Research Laboratory in the pursuit of its aim and objectives. This may include the provision of meteorological data and the equipment of meteorological stations with coordinated technologies to enhance space Earth investigations, from which useful reports may be generated to assist in agricultural development, detecting greenhouse emissions, forecasting weather, among others. Distinguished ladies, gentlemen, students, it is the venture worth chasing in the interest of scientific progress. He believes that the various experts that have been invited to do justice to this topic will do a very great job, and we should all be attentive as to learn from this process. Life is about knowledge. You need to learn until the day we leave the earth. I thank you for listening, and also thank the great people of Edo State, students and staff of Uniben for your support. We remain committed to environmental sustainability, which includes space-based studies. Great Uniben, great Edo State, great Nigeria. Thank you very much.
Thank you very much, sir. Please, we can do more than that for the government. Thank you very much, sir. In fact, when you were even talking, I was thinking that we are having a nationalist in environmental matters. And even the way you were even talking about space, I thought you were even executive director of one of the centers. So I really appreciate your information and everything. Thank you very much, sir. Please, at this juncture, I would like to welcome the Vice Chancellor, Professor F.F.O. Olumesin, represented by the DVC Academy, Professor Iriogbe. Please, may we come out together.
The representative of the governor, Mr. Ike Osanyande. Our former Minister of Science and Technology, our elder, here with us. Professor Emmanuel Morgan. Senator R.S. Owe, we're happy to have you here. Thank you. Professor Babatunde Rabiu, Chief Executive, Director of Center for Space Research. Chief J.O. Ajari, represented the Royal Father of the Day, and J.A. Uswalele, University Librarian, Dr. Omolabi Diodi. Ladies and gentlemen, I feel happy to be here and privileged to read the address of the Vice Chancellor of the University of Benin, Professor F.F.O. Olumesin, fellow Nigerian Society of Engineers. I'm delighted to welcome you all to this workshop on space science and technology, organized by Space Earth Environment Research Laboratory, University of Benin, in collaboration with National Space Research and Development Agency. My sincere compliment goes to the organizers of this workshop for the ingenuity in putting up a program like this. I commend your competence in initiating this workshop. You couldn't have come at a better time than this, especially in this era when there's little orientation about space research and development. The theme of this workshop, space exploration, a step into a new frontier. It's not only apt, but very well chosen. If we must change the lingering stereotypes and cliches attached to rocket science, as it is often called. It's a very difficult aspect of science and technology. I want to assure you all that the university under my leadership will continue to support efforts aimed at improving knowledge and growth for the benefit of mankind. I join all participants who are here to take full advantage of this workshop to enable them acquire and develop new research skills and to tap from the opportunities available from NAFDA in the area of space science and technology. I appreciate you all for making our time to attend this workshop. Thank you.
Thank you very much, sir. Please, we really appreciate the Vice Chancellor's address. Please, we can do more than that. Let's give a hand of applause to the Please, at this juncture, we would like to invite our old father, our Papa, who will also give us a lecture, also with his experience in science and technology, as a former Minister of Science and Technology in this nation. And he's here with us physically. And his major area of specialization is in chemistry. And he's physically present here with us because we want the young people to be encouraged that in life, when you aspire very well, it depends on how you train your mind to you get to the peak of what you want. And our father is here, as a former minister, is here with us. And so humble. And is here to tell us one or two things in the area of his experience and all that. Please join me to welcome Professor Emmanuel Momo. Thank you very much.
Mr. Chairman, would you please permit me to stand with the protocol already established by the VC. So I say, Mr. Chairman, ladies and gentlemen, it is my pleasure and honor to be invited to be guest speaker at the conference of June 2017. Which is being sponsored by the Federal Ministry of Science and Technology in collaboration with the University of Benin. It is a unique opportunity for me to once again talk on issues of science and technology as a veritable tool to advance mankind. My own career has been in science and technology, and I served as a teacher, the researcher, and the policy maker in science and technology. The theme of this conference is space exploration, a step into a new frontier. Space may be defined simply as any region above the Earth which cannot be reached by balloons or aircrafts. It is said to have no limits, continue to expand, and it does so without limit. It can only be accessed by means of powerful rocketry, which was developed to overcome the force of gravity to reach orbital velocity. Rocket engines for space flight were invented and designed simultaneously in 3 countries by three key science technologies, namely in Russia by Rosatom Shutovsky, in the United States by Robert Goddard, in Germany by Hermann Oberth. This innovation made the exploration of space possible. Nazi Germany saw this as a possibility of using long-distance rockets as weapons. After World War II, the United States and the Soviet Union created their own missile programs, all the resources at its disposal to achieve it. It was to meet the challenge posed by the Russian effort in Sputnik that motivated the United States. Thus, on 20th February 1962, John Glenn made the historic flight to orbit the Earth. On July 20th, 1969, astronaut Neil Armstrong took a giant stride for mankind as he stepped on the moon. 6 nations Apollo missions followed and were made to explore the moon between 1969 and 1972. The early era of space exploration was given impetus by the space race between the Soviet Union and the United States of America. Satellites. Satellites are used for many purposes, such as studying phenomena occurring in outer space. Here we refer to artificial satellites, which carry monitoring and recording equipment, including computer, to distinguish them from the natural satellites such as Earth. Space systems will continue to become more and more integral to military defense, weather surveillance, communication, navigation, imaging, and remote sensing for chemicals, for locating fire disasters, and so on. I must mention at this point that some time ago, before the birth of the present center, we tried to establish remote sensing for locating or identifying our resources. Space stations and human crafts are regarded as satellites, including space telescopes. Satellite orbits vary very greatly, depending on the purpose for which the satellites are made and are classified in a number of ways. We have the Internet Global Network worldwide, which is made possible through advances in satellite communication, thus creating the global village. The web is a way of accessing information over the medium of the Internet. It is an information sharing model that was built on top of the Internet. The International Space Center, I'm sure we have been watching the pictures that have been shown to you. That's the typical space station And this is an habitable artificial satellite in low Earth orbit and can be seen with the naked eye from Earth. It serves as a microgravity and space environment research laboratory in which crew members conduct experiments in biology, medicine, physics, astronomy, meteorology, and other fields. The Russian Soyuz rockets are presently the only provider of transport for astronauts to the International Space Center after the retirement of the American Space Shuttle. Hubble Space Telescope. It is a space telescope that was launched into space and managed by the American Space Agency, named after the astronaut Edwin Hubble. It is one of NASA's great observatories. The Space Telescope Science Institute selects Hubble's targets and processes the resulting data, while the Goddard Space Flight Center controls the spacecraft. The replacement is due for launch in 2018. Interplanetary space exploration. This is the ongoing discovery and exploration of celestial structures in outer space by means of continuously evolving and growing space technology. Robotic spacecrafts are able to venture much further into the cosmos than human dare. These missions explore the planets, comets, and other objects of our solar system, as well as the characteristics of the interplanetary media that lies between them. The Voyager 1 extends our reach deeper into space. The craft launched 3 decades ago and is now more than 100 times farther from the sun than our own Earth, which is over 9 billion miles or 15 billion kilometers. Voyager 1 and 2 have studied the planets Jupiter, Uranus, Saturn, and Neptune, and explored their moons, examined their rays, and revealed much about interplanetary elements such as solar wind. The Cassini-Huygens mission is an ongoing international effort to explore Saturn and its target moon, Titan. Scientists hope that Titan, as well as Saturn itself and its rings, may help them understand more about the birth and evolution of our entire solar system. Comet studies. Interplanetary missions have also targeted comets. Many scientists believe that the material that made up comets is relatively unchanged from the time they were formed billions of years ago, when the solar system was young. Comets could provide valuable clues about origin of planets. The National Space Research and Development Agency. Space exploration has become commercial, and every country tries to launch satellites to harvest the benefits of structures in outer space. It is like the scramble for Africa by the colonists in the 19th century. Because of the numerous satellites in space, the efforts being made may be countering each other, leading to waste of resources. And so, coordination policy among countries had to be put in place. This could be a possible step to restore unity among nations. Also, the financial input in space exploration and implementation of the undertaking is so great that joint venture activities are inevitable. Nigeria must not be left out in this race to share from the benefits of space exploration. So Nigeria Space established the National Space Research and Development Agency with ground receiving station, which is based in Lagos. Nigeria presently has cooperation in space technology with the United Kingdom, China, Ukraine, and Russia. Nigeria Sat-1 was the first Nigerian satellite and was built by a United Kingdom-based satellite technology company, Surrey Space Technology Limited. Nigeria Sat-2 and Nigeria Sat-X satellites were built at a high-resolution Earth satellite by SSLT for DMC system. Like I said earlier, space exploration has been undertaken for advancement of scientific research, for national prestige, for fostering unity of nations, and ensuring survival of mankind. The challenge posed to scientific research involved the development of sophisticated equipment to facilitate achievement of success. This development results from human ingenuity, as according to Jim Patrick, and I quote, "The future of high technology is not limited by financial investment. Rather, it is limited by human investment. The numbers of trained engineers and scientists who naturally become poor. These and other scientists are produced by the educational system
the political areas, and everything. And he's a successful man in his own dealings and his own activities. And he has been a father to us over the years. Please join me to welcome distinguished Senator R.S. Uwe, who will just give a little encouragement. Thank you very much.
Glory to Jesus. My children, you are welcome. Praise the Lord. Now you are talking. Your Excellency, our Father, Royal Highness, the Lord of Benin, and that protocol observed. I want to thank God and thank the director of the Center for Atmospheric Research for knowing that where there is no justice, there cannot be peace. This center that mine in Edo State, I knew the pressure all of you went. It was supposed to be out of this zone. Before just we created in Nigeria, there were 4 regions. The northern region headquarters in Kaduna, the eastern region headquarters in Enugu, the western region headquarters in Ibadan, and the midwest region headquarters in Benin. But when things are coming to south zone, people are not looking for the center. Where is center? In the southwest, you are not talking of center, it's Ibadan. In the north, you are not talking of center, it's Kaduna. In the east, you are not talking of center, it's Enugu. Admiral Center, and may God bless you. That thing is in Benin. You did what Admiral Afun did, may he still rest in peace. When NAPTE was being located, people said you should go to Port Harcourt. Admiral Afun said no. Benin City was the 4th region and 4th headquarters. May God bless you for bringing it to Benin City. And I want to thank our son, the Vice Chancellor of Benin, who quickly took that thing without waiting time. Mama will know. A home where there are parents to have 7 wives, 10 wives, 9 wives, my daughter don't look at that. The night it is the turn of the 7th wife, let the first wife go and try. Now fight. It is turn by turn. When it's your turn, you come in. If the turn is not ready, it's a different thing. Midwest, 4 region, it was our turn. For NAPTE, others were struggling with. The same thing. I bow for you, God bless you. So we now have the center here. The University of Benin and our students, you must make use of it. Go back to your institution and learn and study. Papa, who just spoke now, former Minister for Science and Technology. He didn't start it. He started it from the local chemistry. We knew him wherever we are moving more for years. Those who are not even related to him, once they live here, they will say, yeah, now our papa. Like the good man that they claim. We as women claim successful children. Because the moment, yeah, the one that mama will say is his own. But when it's an arm robber, I will say like the woman like one. So, you should go and learn so that you can get advantage of Space Center product. May God bless you.
Thank you very much. You know, some person might be thinking that if we want to turn here to a campaign, I know that many of us have been informed with some certain things. We believe that every time you don't just be too academic, but at least you have 1 or 2 persons who will also encourage you. And when you see them, you know that they have also traveled far and wide. Please, once again, let's clap for our father for a wonderful preparation. Thank you very much. Please, at this juncture, I would like to welcome our own digital director. We call him digital director because he is not operating in a crude apparatus. He operates in the digital way, and also he operates in space in things that imagine that you cannot just think about it will happen. There's no other person than Professor Babatunde Rabi, the director and CEO of Center for Atmospheric Research. Thank you very much, sir.
The representative of the governor of Edo State, our own grandfather of science, the former Minister of Science and Technology, Professor Emofon, the Royal Father of the Day, and distinguished Senator of the Federal Republic. Other protocols duly observed, but I must especially acknowledge our mommy, grandma, God bless you, ma. Students, ladies and gentlemen, I will be giving a very brief presentation, so I will want to run through many slides just to give you an idea of what space is all about. Our grandfather spoke about this, and I got lost really, because I was wondering what else will I do other than to show you pictures. That's the only thing he did not do. He told us, as he was speaking, I got carried away. I tried to translate myself to his age and wonder if I would be able to remember all those things. Thank you very much, sir. He has touched everything, so I will show you. He mentioned Yuri Gagarin and so on. I will show you some of the pictures of Yuri Gagarin and some others. Space is a step into a new frontier, and he's talked about what he has given the definition of space, and in today's context, he just referred to every other location, the entire objects and locations in the universe outside the Earth, the stars as well, including the sun, other planets, and their moons. He was talking about the Saturn, Jupiter, and so on and so forth. He actually said everything. So you just permit me. You see the lining up of the sun on now on your own side, that will be on the left side, and then you see other planets moving around the sun in their respective orbits. The universe is made up of several galaxies. We want to ask questions: why do we bother ourselves with space when we are not yet through with the Earth? He made the point with respect to the statement made by the one-time President of the United States of the need for them to put the first man on the moon before the end of that particular decade, and it came to pass. If you can utilize the space, you can solve a lot of problems on this present Earth. We are going to discover that as we go ahead. The universe is made up of several galaxies. A galaxy on its own is made up of an aggregate of stars and planetary bodies. Scientists will tell you there are billions of stars in one galaxy. And our own Earth, where we are, is a planet that exists in one of these galaxies. So there are many galaxies in the universe. We just exist in one. And that one in which we exist is called the Milky Way galaxy. And the sun that we see is one of the billions of stars in our whole galaxy. We have many other stars all around us. A star on its own is a ball of hot gases. A star is not solid in any way. It's gaseous throughout. It's gaseous, and the sun, which is one of the stars, is a dynamic star with a radius of about 696,000 kilometers, and it rotates. This sun you see is not static. It rotates about its own axis, and you can see some emissions on the lower panel there coming out of the surface of the sun, and you can see the granules. Like when you look at sugar that we pour into tea, you know it's granulated. Or you know gari now, you call it cassava flakes, but it's gari actually, okay? Now, that's how the surface of the sun is. It's not smooth. It's granulated on the surface. Very energetic, highly magnetic stuff. And it is the sun's photosphere that we see And the sun actually rotates. That's a picture of the sun rotating. And those black spots that you see there are the dark spots on the surface of the sun. These dark spots are the active regions on the surface of the sun. And it is from those active spots that it emits huge amount of radiation that comes towards us. And the sun emits radiation in all directions. In all directions. Well, that's about the sun. And the radiation comes towards us, but we are shielded from the radiation by some layers of the atmosphere, especially in the regions in the stratosphere and where we have huge amount of ozone. Now, the Earth's atmosphere is made up of a mixture of gases, as you are aware of. The major composition there, the majority is nitrogen, which consists of 78%. We have oxygen in about 21%, and there are some other gases there in the atmosphere. The atmosphere, as you know, normally we refer to it as the region that surrounds of gases that surround the Earth. From the surface of the Earth where we stand now, and you move up to wherever you can find gas, we call those regions the atmosphere. And even where the gases exist in ions, we still refer to that region as the atmosphere. And the Earth's atmosphere is classified into different layers. We have the lower atmosphere, we have the upper atmospheres, and we have some other regions of the atmospheres. We are concerned about the atmosphere because it is in that region that the air that we breathe in occurs. So we are interested in environmental pollution. We want to know the quality, the air quality, and we're also concerned about the upper atmosphere because it is in that region that we have satellites. Today there are thousands of satellites in space, and as I will show briefly, you'll discover that the world today depends on space technology. I'll get to that very soon. The upper part of the atmosphere, where we are not living, because we are down here, talking of altitude of about 40 kilometers, is made up of upward, is made up of ions. And this is coming from some of the data that we put together and we plotted in ionospheric research. You can see the atmosphere over everywhere is being closely monitored, but you can see that of Africa is sparsely monitored. And that is why we are here. We are now trying to bridge that gap. This is taken from some ground observations, including one equipment that we now have here in Benin, the GNSS monitor for space weather. That is how the atmosphere appears to be boiling. The red color shows highly intense electron content, and this can actually knock off communication gadgets. When the ionosphere is boiling, you may not be able to receive phone calls. When it is boiling, navigational systems can knock down. If you are in the air, at that point in time, you can hang in the air. Like last Friday, traveling between Kano and Abuja, we had to stay in the air for about 1 hour extra because the weather was not so comfortable. If we had had the detailed knowledge of weather, we wouldn't have left Kano. We were about to land, just about 50 miles to Abuja. The pilot announced to us that we will not be able to land, and we spent extra 1 hour in the air. You can imagine the amount of resources that went into that. The tension, the emotional value, and the cost of the fuel, simply because in Nigeria we are yet to master our atmosphere, and that is what we are doing. And so it's actually a new frontier where people are going to. Space-based technologies have continued to ease the burden of terrestrial men in almost all human endeavors. Today we send emails. Today we make phone calls from the comfort of our bedroom. We do financial transactions. I don't need to get into bank. I can't remember the last time I write on my checkbook. I don't even know where my checkbooks are. And the world has gone electronic, and because of the space-based technologies, we could link communication from one point to another via those things that are listed here: satellite technology, navigation technology, information technology, communication technology, as well as power systems. All this depends on space-based technologies which are domiciled in the space environment. And these are some of the products. Almost everyone is familiar with the ATM cards, right? MasterCard, Visa card. You watch live Premier League. Who has won the Premier League? Right? Good. And you can watch live. You could watch the match live, you could scream, and you feel free. And then you have cell phones, all manners of cell phone. And all this connectivity has been made possible because of space technology. And the global navigation satellite systems now is turning the world into something else. Now we have self-driving cars that you just have to program from Benin, and then you land in Lagos. You don't need human driver. You sit inside it. In developed nations of the world today, in some of the major cities, you are warned that the car ahead of you may not have human driver, so drive carefully. So because they have been programmed and they all followed global navigation satellite systems, which is rooted in space. The US launched their own navigational satellite system first, followed by some other countries of the world today. And it's made up of a system of satellites in constellation. And they orbit. Each of them is at about 20,000 kilometers from here. If you are chanced, please pay a visit to the Space Environment Research Lab here in Benin, inside Uniben. You'll see the antenna of the GNSS systems. With that antenna that is on ground, is able to receive signals from about 20,000 kilometers in the sky. And then you can relate this on the systems. This is the power of space-based technologies. And that is why the present has come to belong to space, and the future also belongs to space. These are some products of space-based technologies. The tropospheric weather report, telephony, transactions of business with a credit or ATM card, online or mobile banking, navigation by GNSS, surfing the internet. When you do WhatsApp, you are patronizing space-based technology. When you Skype, you are patronizing space-based technology. When you watch cable televisions, CNN, Africa Magic, what have you are doing nothing but patronizing space-based technology. When you travel by air, navigation is done nowadays by GNSS. Even the modern military warfare, people no more fight battles using, recently North Korea fired missiles and it landed very close to Russia. You can just imagine, from North Korea, the missile landed very close to Russia. Just one more push and it will be in North America. And so we are in a very tight time where every nation, just as our erudite professor and grandfather of science has spoken, every nation must master its own space, and every nation must develop its own science, and this is what we are doing. And that is why we have students here like him. They've done a lot. He mentioned they started what is now the Space Research and Development Agency. They set up the National Center for Remote Sensing. We now call it National Center for Remote Sensing, sir, and it's located in Jos, but has some ground stations in some locations. Thank you very much for doing that for us, sir. They started it, and when the Space Agency came on board in 1999, the center was incorporated into space program. And so it remains the oldest center of the space agency. So the modern military warfare is now done by drones. It's done by drones. No casualty. No casualty. You don't need to send men to war fronts. You just need to use drones and you scatter the enemies. You just program drones from here inside Uniben, and the drones can land in Sambisa forest and do the magic that 1,000 troops can do. Unmanned area vehicles, which we call the drones. Now we have e-health, telemedicine, autonomous area surveillance, where we use space technology to survey environment. You take satellite, you use satellite imagery, you take pictures of environment here and there. Well, I don't want to really waste our time. Space. Another issue in space today is space weather, and it captures the interactions between the solar wind. You see, Prof mentioned that solar wind. These are radiation that comes from the surface of the sun, and they move at a speed of about 1,000 kilometers per second from the surface of the sun. About 1,000 kilometers per second from the surface of the sun. That is 10 raised to power 5 meters per second. That's quite enormous. When you travel in a moving car, you want to move at how many kilometers per hour? But the solar wind moves at 1,000 kilometers per second, and they march towards us. They dominate the space environment and dictate the weather in the space region. And I tell you, this is what we monitor with the equipment here. That's why we say it's for space weather monitoring. And like terrestrial weather is very pervasive and challenging. And it has a lot of implications. About a few months ago, it knocked down the navigational systems in Sweden. They had to announce that no flights, for some minutes, no flights, because of space weather effects. We are yet to get to that level in Nigeria. It is the duty of our center to provide space weather alerts. And right now we are discussing that because we have some equipment, including the one here at Uniben, that is going to be helping us. So we're working out the modalities. But there is also one that is being used for international community, but we're trying to carve out our own national space weather alert. With that, you'll know when to fly and when not to fly. Well, space technology, like we said, is a new frontier. It has become a major driver of sustainable development in agriculture, precision farming, in financial transactions, you agree with me, in education, to eradicate illiteracy, in tourism, in land administration. Most states today are talking of GIS, and through GIS, the government revenue base has greatly improved, because with that, you know where the land is, and you know the correct size of the land, and then you know what you are selling, and you know what you are taxing people for. I want to tell you that sensible state governments in Nigeria are taking good advantage of GIS. They are setting up their GIS facilities so that they can actually utilize it in land administration. Also for military purpose, for social security or public safety, navigational systems, I've emphasized that, poverty alleviation, and communication. Space technology has tremendous derivable socio-economic benefits. Well, these are some reasons why we study space environment. If you have crisis in space environment, it will affect satellites. It will affect the performance of satellites. It will give wrong information. It will affect all the facilities that depend on space-based technologies. It will affect your financial transactions. You make phone calls and the other guy will not be able to hear what you are saying. And nothing is wrong with your cell phones on either side. It gives navigational error. You program your plane to land you in Lagos, you find yourself in Abuja. Starting off from Benin. It can lead to 1 meter error in targets can be very disastrous, especially in warfare. It gives it gives satellite drag, and it causes what we call the geomagnetic induced currents and some other problems. And that's the reason why actually we look at space environment. Space also affects animals as well. It affects migration of certain animals. And you know that the troposphere, where we have the tropospheric weather, is part of space. When the weather gets hot in some places, some animals migrate to a more conducive environment. And we have some other effects. One very interesting statement made in 1926 by a scientist, a physicist known as Tesla. How many people are in SS2, SS1 here? You know Tesla? Who can tell me, a student here, what is Tesla? It's a unit of something, a boat student. That's the only question I want to ask from you. A boat student? Tesla is a unit of what? Somebody stand up and say it. Come on. Yeah, that lady. Tell me. The unit of what? Magnetic intensity. I have a gift for you. Don't go away after this, okay? Please give him a round of applause. We train our students to be bold. When you have a solution to a problem, come forward. Is that all right? Go. Don't shy away from giving solution. Tesla is the name that is given to the unit of magnetic intensity. He made a statement in 1926. In 1926, when there was no satellite, the first satellite was launched in 1957, and then there was no wireless telephone by that time. Wireless telephone came into existence during the World War in 1940s. But this man, as a scientist, made a statement. He said, when wireless is perfectly applied, the whole earth will be converted into a huge brain, which in fact it is, all things being particles of a real and rhythmic whole. He said, we shall be able to communicate with one another instantly, like we are doing today. You can communicate with another person irrespective of distance. Somebody can be in Chicago and you can communicate with him here in Benin. Somebody can be in Abuja and you can still communicate with him. He said, not only this, but through television. What he was describing then is what we call the video calls now, which you do on your WhatsApp, right? And telephoning, he said, we shall see and hear one another as perfectly as though we were face to face. Now you Skype with people, right? This man made this statement in 1926. He was never privileged to see it. He said, despite intervening distances of thousands of miles, he said, and the instruments, he did not know the name of the instruments. He said, the instrument through which we shall be able to do all of this will fit in one of our first pocket here. You know, that is the power of science and technology. And this is the reason why we're here today. People sitting here, you have the solutions to the problems of Nigeria, and it is by science and technology. We're going to make the speech delivered by our erudite professor emeritus and former Minister of Science and Tech available on our webpage. Before we sleep this night, it will be on our webpage for people to read. It's a very powerful speech that must live beyond this generation. Science and technology has the key to the present crisis in Nigeria and anywhere. You can just imagine. Telephone is the name of the instrument this man was describing. He tried to imagine what it will look like. He said, and the instrument, and now we call it all manners of names. And well, I will want to quickly come to an end and tell you what space research does, or space exploration, and does to people, and the relationship between that and mental education. Study and exploration of space has led to the discovery of several equipments that have come to be valuable in our day-to-day life, like scanners, photocopiers. Photocopiers came by space exploration. Scanners came by space exploration. Telephoning came by space exploration, and some other facilities also like that came through space exploration. And another thing it does to human's mind is that it excites our mind and raises the level of curiosity of any student. You want to imagine how the earth is moving around the sun in its own orbit and it does not miss its trajectory. Pluto, you know, was once a planet. You know why it was deorbited? Because it misses its orbit. It could no longer keep its track. So it was not consistent, so it was deorbited. And it enhances the IQ of students and unlock potentials of human thoughts. And that is why advanced nations of the world today spend tremendous amount of money on space for delivery. I will skip this, but of course you should know by now that on Thursday, 23rd July 2015, NASA announced the discovery of another inhabitable planet, which is Kepler 452b, which is known as Earth 2.0. So we are living in Earth 1.0 right now, and very soon people will be traveling to live in Earth 2.0. Is a planet that you can survive on it. Well, I just showed some pictures now at this point. That picture there gives the first satellite, the picture of the first satellite, Sputnik. And I want to assume that the speaker that is coming before me may give that. That was the simple design, and that was the first object that went to space as satellite on 4th of October 1957. And that is Yuri Gagarin that Father mentioned the other time. And in 1961, he became the first woman to travel into space in Russia. And he had a flight time of 1 hour. This was mentioned by Daddy as well. And he landed safely in Siberia, and he became an hero thereafter. That was the guy, and he lived for 7 years thereafter. His death has nothing to do with his going to space. Actually, his death was due to some other reasons. It was a painful loss to mankind. Anyway, but that was him when he was being projected into space. Well, this movie clip may not show, and it may show. Let me give it a try. Oh, that was when he was taking off. That's the way you were showing you got the volume. Hello? You got the volume out the other time. It's a short movie of Yuri Gagarin. takes a blast to leave our environment. There must be a blast. It's not easy to exit. And that was what really happened when the guy, that was the first experience, and it was well recorded, and Yuri Gagarin zoomed off in that particular system. Okay, so at this point I will just show you what this Nigerian Space Research and Development is doing since 1999, and it remains an establishment of the Federal Ministry of Science and Technology. Now we have grown to have 7 different centers with different responsibilities littered all over the country, and our Center for Atmospheric Research is one of the centers, and we are located somewhere in Kogi State, and we set up some laboratories in the country. We have one here at Uniben, we have one in Abuja, and so we are dedicated to research and capacity building in atmospheric and related sciences, and we maintain our focus by getting involved in observations. We set up experimental facilities in different parts of the country to monitor the Earth's atmosphere at lower level and the space environment, and we are involved in training, in capacity building, and in outreach as we are doing today, and we get involved in research as well. We have some key research projects, and we are into atmospheric chemistry and environmental research as well, where we study the environmental pollution, the air quality, and we still look forward to set up more facilities to study thunderstorm and lightning and air quality at different parts of the country. I've mentioned that we have a laboratory here, which is a super laboratory, really. And there are 2 others I've not mentioned. We have our National Air Quality Research, which is located inside the University of Ilorin. And we now have a Space Weather and Atmospheric Physics Laboratory, which was commissioned last week at the Bayero University, Kano. These are special space research laboratory. The pictures, the slide on board is the one of the Space Environment Research Laboratory in Abuja, and this one has a facility that captures the space environment. Is able to capture where you have the red circle. Sitting in Abuja, it can cover up to 500 kilometers away from Abuja and into the sky, and it can tell you what happens in the upper atmosphere in the night. And that is the movie of what happened in over Nigeria on 21st of June 2015. And over 4,000 people have visited that laboratory. The one here in Benin, which was graciously provided by the University of Benin, thanks to the management of the institution, very responsive management, and who provided the facility, the building, and the accessories in the building. And we started activity on 1st September 2015. Incidentally, on that day we have an annular ellipse, and the lab has continued to witness growth. We've put an equipment there, which is in the network of the continuous operating reference stations of GNSS. Well, we're so happy that this is useful, that the facility is useful for the staff, students of Uniben and some other people that are coming around, thanks to the head of Department of Geomatics, Dr. Ijato, who came actually to confirm that our system is actually accurate. So, for the students here, these are some of the programs that can benefit from what we do as a unit of space agency. There are some other aspects The space agency is into satellite engineering, satellite rocketry, satellite development, and we are into atmospheric research. The agency is also into remote sensing and some other aspects of space program is covered. These are few aspects that we get involved in. Apart from just atmospheric research, we are into environmental studies, into agrometeorology, and we are into energy studies as well, but we do radiation studies. And we offer a lot of opportunities. As a matter of fact, in our center, we have a slogan that we create opportunities. And for you as students to develop career in space science and technology, which has been emphasized by our erudite professor, you need to take science very, very interesting. Mind you, it's not only scientists that we have in our space agency. We have administrators, we have people in economics, we have marketers that market our satellite imageries. But if you want to develop career in space science and technology, then you have to take your science very, very interesting. Your physics, your chemistry, your biology must be very sound. Your introduction to technology must be very sound. And technology is very, very crucial, as well as engineering. And the basis of this is what? Mathematics. Mathematics is the key to science. So at this point, I want to say thank you. And with a wave from Yuri Gagarin, I say thank you once again.
I think you have seen now physically, I was not just exaggerating. You can actually see that it's a digital director. Please, once again, let's clap our hands together for our digital director. I know that the country we are building in Nigeria, that when you talk, you do. That is the Nigeria we are working towards. And that is the Nigeria we started seeing. We are not telling you the National Space Agency. So many people were asking me, do we really have National Space Agency in Nigeria? I said yes. Even in this way I'm standing here, people were asking me. I said yes. But I know many of you don't even believe that such equipment were even found in Nigeria as we speak now. Please, there are so many things that's happening in this country. We are nice people. Let us stop the idea of destroying ourselves. We are intelligent people. The only thing we need now is for us to accept each other. We accept each other, we appreciate each other, and we value each other. And whatever any of us is able to do, we should encourage each and every one of us. Please, for your presence here, let's clap our hands together for ourselves. Thank you very much. If you remember, for those who have opportunity to get the details of the program, we said Space Generation Advisory Council is a representation of those who encourages students in the whole world. Is our encouragement of space generation to encourage young people on space science and technology. And we have a representative, the Nigeria chapter representative is here and is led by Mrs. Fumi Orifola. She's here with us. Please, if I bother the name, forgive me. Thank you very much. Please, let's jam our hands together for her, who will give us the details of other part. Thank you.
Thank you very much. Don't worry, it's allowed. Erin Folami, that's the name. Thank you so much. Good afternoon, sirs. And I'll start with greeting the chairman of the day, the executive governor, represented by Mr. Ike Osanyede, and also your grandfather to me, Professor Emuva. I'm so highly privileged to meet you here today. You're welcome, sir. And greetings also to Senator Owen. I hope I mentioned the name right. Okay. And then representing the Royal Father of the Day, Chief Ajari. And also to all the principal officers of the university, and then my Oga within the space agency, Professor Babatunde Raji. You have always been an inspiration. God bless you, sir. And to all the students here, ladies and gentlemen, I welcome you to this section, which is actually meant, we are here because of you, because Space Generation Advisory Council is about the young people. It's about representing the young people in space affairs of the world. So we are here for you today. And I'm just going to give you a brief of what this whole session is going to be about. We have this presentation about astronauts, where astronauts stay in space to work and sleep. And then I talk to you about the kind of suits they wear when they're in space and they need to go outside the spacecraft to do perform any operation. We talk about that. And then you also learn a little about one of the space agency's centers, which is in Ile-Ife, Center for Space Science and Technology Education. For those who might be interested in picking up something on space science later on, either after university or for those who are going into the university now, we run postgraduate programs and master's programs. So if you want to become a space guru, yes, you can go there. And then we have representatives of the Space Club, OAU and FUTA, and then SGSC members who have actually developed, designed and built this drone we have here. So today you have the opportunity of learning about the basics of this design, so that for other university students or even the secondary school students who are here, you can actually try your hands on building this. Drones are useful for agriculture, for mapping your environment and things like that. They're useful for that, so you get to know about that. So and then for those who are within Benin, the main icing on the cake for us today is we'll have the privilege of having an astronaut join us on a live Skype session, but that's after we've flown this drone, And so the astronaut is going to join us, and then you have the opportunity of asking questions. So please, the reason this presentation is coming on is so that you understand who astronauts are, what they do in space, so that would help guide the questions you will have for the astronauts. And please just scribble down your questions as we go on, so that we won't waste time once that part comes up. Thank you. So, who are astronauts? I will try and go really fast for this. Astronauts are people who work, they train on Earth, and then they work and live in space. But definitely for short periods of time. Though, right now, more is going on into making man stay longer in space. We've actually celebrated an astronaut who stayed for a whole year in space. And I mean, in space by our own terms, when you measure from the surface of the Earth, from 400 kilometers upwards is space. And we have this spacecraft, which our father here has already mentioned to us in his speech, the International Space Station. So this is just a group picture of some NASA astronauts who went to space some time back. And this is also, you can see, this is actually an astronaut who's doing like what we call an extravehicular activity. It's actually just a cord that is holding him to the spacecraft. I bet if it's any of us, it would be so scared. Like, I don't want to drop all the way down to it. So, and in different languages, English is an astronaut, in Russian, language is called a cosmonaut, and in Chinese, language is called a taikonaut. And so I have, of course, I'm sure by now, that name Yuri Gagarin should at least stay with us and go with us. Who is the first human in space? Valentina Tereshkova was the first woman in space. Of course, I'm sure a good number of us would know the name Neil Armstrong, who was the first human to walk on the surface of the moon. And then the young Louis is the first person that was sent to space by the Chinese. And then what do astronauts do really? They do science, they do research, they teach, they do outreach, that is inspiring those of us on Earth. And those researches they carry out basically is in different areas: agriculture, medical, medical sciences, and then they encourage us, like I mentioned. And another thing they do actually is arts through photography and music. And if you remember the video clip we showed earlier, you know, the lady astronaut actually mentioned that viewing the Earth from space is one of the moments they live for, because it's always breathtaking. And the picture over there is a female astronaut who is actually working with mounting a video camera, you know, in space. And this is, you know, I told you the astronauts do a lot of things. Mind you, if you're training to become an astronaut, you learn the science parts, the technology parts, because if anything happens to your craft, you have to know and understand the in and out of your craft so you can do repairs. They can't send engineers from here, so you have to be the engineer. So that shows you some astronauts who actually are doing an extravehicular activity, fixing an issue on their spacecraft. And of course, more pictures of astronauts in space. And that actually is a whole section on it. So I need to mention here that because the astronauts live under microgravity condition in space, there is this effect that happens to them when they don't really use their legs for a long time. They practically float most of the time in the spacecraft. So there's a tendency to lose muscle mass and then bone density. To counter effect those things, they actually do exercises. So you notice this astronaut on the bike who is also reading. They do all those things, you know, to actually try to maintain the firmness of the muscles and then the bones, so that when they come back to Earth, they won't be too jelly-like, you know, to walk. And of course, it should interest us, we have students here, it should interest us to know how we can be an astronaut. Well, someone with a bachelor's degree in physical science, engineering, mathematics, or biological science, and at least 3 years of professional experience or an advanced degrees. But mind you, for the secondary school teachers that are here today, even experienced teachers are encouraged to apply, mostly secondary school teachers. So, if you're a teacher here today and once Nigeria has its own space program, you're free to apply to train to be an astronaut. There's room for you. And of course, selecting and training astronauts, I just need you to know it's a whole lot of rigorous work, because you can imagine, just try to imagine you have an aeroplane and you need to know in total the working of that aeroplane, such that if it beats a light or it makes a sound, without thinking too much, you know where that is coming from. So they do all of that. And of course, they screen them psychologically. They want to be sure that when you're up there in space, suddenly you don't have some kind of a psychological breakdown or something. So they do all of those screening. And of course, naturally, medically, they want to be sure your heart is pumping well. You don't have any form of ailments that can become aggravated, you know, under microgravity condition when you travel to space. And then, of course, the years of training they do military water survival training, scuba diving, flying, you know, and they learn to deal with emergencies under high and low atmospheric pressures. And why is that? Because under different atmospheric pressures, there's a tendency that the way we process things, you know, can be hindered. So for those who have that super ability under any pressure, so to say, they can really perform. Those are the kind of people that eventually end up being, and of course, as part of the training, they learn the Russian language, because mostly they have a major facility in Russia where they learn, though they go to different parts of the world for the training, some in the US, Canada, and then Russia, but they need to learn the Russian language because they do a whole lot there. And of course, robotic skills. And of course, how many astronauts are there in the world today? About 646 who have trained so far. And out of those, 558 have traveled to space from 38 different countries, hoping one day that Nigeria is going to join that particular list. And now, so I want to talk briefly about spacesuits. Spacesuits is the suit, that is the clothing that the astronauts put on when they have to go outside the spacecraft, like Neil Armstrong. In fact, the space suit you're seeing on your right was what Neil Armstrong used when he landed on the moon. And the one on my left was the first kind of suit that was designed for astronauts. But of course, as technology, continued to improve, they were improving their spacesuits. And why do they need spacesuits? My prof, Professor Ravi Mayoga, already mentioned before, he talked to us before about the space environment. You have very harsh particles, damage particles that can, if they hit the humans, talking about radiation and things like that, they can cause serious health hazards. So, and then teeny tiny particles, even as tiny as like a sand particle, if it's flying in space and it hits this laptop, it can cause a dent because it's flying at a very, very high speed. So the astronauts, when they go out of the spacecraft, they need to be protected, from such things. And of course, part of why you need a spacesuit is the spacesuit is like a complete mini room for them because there's no oxygen in space, so it has an oxygen pack. And then it helps their body fluids to remain and not to freeze and not to boil off more like because of the extreme changes in temperature. And of course, like I mentioned before, exposure to various types of radiation protects them, from it. I already told you about extravehicular activity, and this is just parts of the spacesuit and its function. I don't want to dwell so much on this so we can move on so fast. I've already talked about this also. These are just the different types of suits that we have. The orange looking one is the most recent that is being used now. And of course, how long does it take to dress up in a spacesuit if they want to do EVA? It takes up to 2 hours. And you have a spacesuit engineer actually that specially designs and tests those spacesuits here on Earth before they take them to space. And it costs $12 million to make the modern spacesuits used for EVA. That's a whole lot of money. Anyway, the space industry is a very, very expensive one anyway. And in future, when you and I probably want to go for a space holiday, this suit here might be what we will be wearing. And then this takes me to the International Space Station, which happens to be where the astronaut will be talking with, also visited and spent about 10 days. So, a little history. The big space stations of the world thought to themselves, why not let's collaborate? Because before then, each nation was doing its own space program to show its might and powers. But they found out that if we really want to go far, then if we come together, put our strength together, then we can really go far. So that was what brought birth of the International Space Station. And it was launched in 1998. And it cost $150 billion, and is the next brightest object in the night sky after the moon. And over 15 countries are participating. And actually there's a news alert you can get if you're interested to know whenever the ISS is passing over your location, for example, Benin. I do that, I get alert, and so I get to see it when it's flying over my house. And you have operation and management centers around the world that will manage and track and ensure everything is going well. And these are facts about the ISS. It's actually the largest man-made object in space and the most expensive. It's 400 kilometers above the Earth, and it moves at a speed of 17,500 miles per hour. And each orbit around the Earth takes about 92 minutes, which means it goes around the Earth, so I think up to 16 times before the end of the day. And of course, it's visible to the naked eye. Be able to make it out. It's passing over at night or dawn, and weighs 419,455 kilograms. And it gets up to maximum 90 kilowatts of power supply by an acre of solar panels array on it. And it takes a whole lot of digital, time, infrastructure to get it going. 52 computers control the ISS, and more than 100 telephone booth-sized rack facilities can be in the ISS operating the spacecraft systems. And health. Medical effects of long-term weightlessness include muscle atrophy, just like I mentioned before. And to combat that, they exercise by strapping themselves to the treadmills with bungee cords, because they are weightless in the ISS, so they practically float around. So they need to tie themselves to the treadmill while they're exercising. And these are just, this is just pictures. You can see, let me go back. That woman, you can see that is actually one of the moments they live for, like they say. It really, really evokes lots of emotion from them when they're looking down at Earth. And truly, they say the Earth looks like a blue big ball when they're looking at it from space. And there are some major features on Earth that they can see, like Great Wall of China. They can see cities and see it even by what we see on the maps. And also, most especially at night when they're passing over, they can tell, oh, that's Paris, oh, that should be somewhere in Africa, and things like that. And in fact, it's such that I can't remember the name of the astronaut, on his birthday or something like that, the daughter requested that they do Happy Birthday Dad, and they actually wrote the Happy Birthday Dad somewhere in the US. And when he was flying over, they actually saw the Happy Birthday Dad. So it's awesome. I would actually really, really love to be an astronaut. And I hope one day, very soon, I will be able to be one. So I don't know about you, but I might be the first Nigerian astronaut. This is just a short clip talking about sleeping on the ISS. We may not be able to finish the video, but we can always view it later. But it's just to so the astronaut speaking is a foremost Canadian astronaut. He's very popular and well respected both in Canada and around the world.
Completely relax. And you can even go in space. You don't even have to hold your head up. So you can relax. Every muscle in your arms float up in front of you. Your head tips forward. But before we go to sleep, we're going to put it on the tanks. That's how space is. Great. Super comfy Russian full-length pajamas. Nice for when you have to get up in the middle of the night. Ready to go to bed.
Like I mentioned before, they don't walk. They practically just float around. They need to decrease
Sleep lab. This is where I spend 8 hours every day here on board the space station. It's actually on the floor. So once you're inside, you just can't tell.
So that's him trying to get himself into his sleeping bag. And like he said, it's tied to the wall so that while he's sleeping and maybe tossing and turning, he doesn't start floating all over. But then, you can imagine for those really long big spaces, you may want to think twice if you decide to go to space because you see those tiny spaces they sleep in. Most especially those who are claustrophobic. So he's telling you good night. Good night, Chris. So, thank you everyone. Mr. John Nesta, please, can you come close? Mr. John Nestor, please, where are you? Okay, I just want to tell you briefly about the Space Generation Advisory Council. For those who are between 18 and 35 years old, you are very welcome to be a part of us. We do a lot of research, and not just research. We come together and look at topical issues in the space industry, and we lend our voice to such issues at the United Nations. So, for example, this program we're having today, we will give a feedback to the executive office in Austria to let them know, oh yes, we actually had this and was successful. So for anyone who may be interested in joining us, you are very welcome to be a part of us. You can visit www.spacegeneration.org, and then you can sign in to be a part of us. I will call on the SGAC and Space Club guys. Peter, please, can you come forward and take over the presentation for the drone? So I'll hand over to Mr. Peter Akweve. I hope I called your name right.
Good afternoon. As I know existing protocols, today I'll be talking to us on what I call unmanned aerial systems. An unmanned aerial system quickly involves the unmanned aerial vehicle, which includes a drone, could be a fixed wing, could be a rotorcraft. So, what is an unmanned aerial vehicle? Well, an unmanned aerial vehicle, as the name already implies, there is no human pilot present in the plane, and it flies aerial, so it's a vehicle. And also, it's powered and does not carry a human operator, uses aerodynamic forces for generation of the vehicle's lift, and can fly autonomously, be expendable or recoverable, and can carry weapons. So, we almost have heard of, or most of us have heard of, US drones killing people in Afghanistan and all that. So there are two major types of drones. We have the fixed wing, we have the rotorcraft. So fixed wing, as the name also implies, involves something like this. So as you see there, on the right side, lower right side of this, we see a rotorcraft. So these ones generate vehicle lift by having this. We can call them spinning wings. So generate lift by spinning propellers at high RPMs to generate lift. So for the fixed wing, their main advantage is longer range, longer endurance, and more payload, because they don't rely on the power from the engines, which suck up most of the power for generation of the lift. The lift for a fixed wing is generated by the wings, mostly. Let's say over 90% of the lift. The others only contribute drag and weight. But the rotorcraft generates all its vehicle lift from the thrust provided by the engines. So from the one we see here, there are 4 identifiable engines there. We can call them engines or electric motors. So they generate thrust by pushing air downward, and as you know, for science student physics, every action leads to an equal and opposite reaction force. So by that, they generate lift. But now, why do you say, what do we need UAVs for? First of all, you won't take the human out of the cockpit and design a plane not to fly with a human if it wasn't for a reason. So for that, because if you have a human being, for example, to come here and let's say clean this stuff every day, they might come the first day of the job and clean this whole place, clean everything neatly, because that's the first day. But as time passes by, the day might come and look, this part is not dirty, I won't clean this part. So that's just a little example, maybe a good one, of what can happen when you have human beings monitoring power lines, pipelines, windmills, and all that, which are some of the civilian roles of UAVs. So if you have a UAV, you can, with advanced software, help you detect faults and dangers and intrusion and all that happen to a property. Then for military roles, you have those especially from the US and Israel and all other heavily militarized countries for reconnaissance, elimination of unexploded bombs, prevention of territories, and so on and so forth. So today, I have to show you how, just briefly, how one is designed with this flow chart. You can see you start from the conceptual design, then you go to the preliminary design. Also, from the conceptual design, you can get the detailed design. You can get the detailed design of how you want this road to look like. And also, so I think the flow chart should be available because of time. Then we've had in OAU Ilefe, we've had several drones. We tested them to know the strengths and weaknesses of different configurations. And seen here is one of them, having a rear-mounted engine, single one. It might be more efficient power-wise since you have just one engine. And this is UAV during launching. It's hand-launched and performs its duty and comes back to the ground. Then the second prototype which we have here, I'm going to show you. We won't be able to fly both of them because of time. We'll fly one of them. So this second prototype was designed to fly for at least 50 minutes, carrying a payload of 1 kilogram. We have cameras that can be at least 50 grams, almost around 50 grams, 100 grams, and all that. So these cameras mostly are very light. So carrying a payload of 1 kilogram is a lot of payload, which can include infrared cameras, LiDAR sensors, and all that, depending on the nature of the mission. And this is the brief summary of the construction. So the material chosen was styrofoam, polystyrene foam, which has the quality of being light and also can be modified to be made stronger. So achievement of the set goals: completed 60 flights so far since December last year, and taking several pictures of our campus in Ife. So seen here on the picture to the left is factory hall of residents in OAU, and to the right is one of the first places you get to on Ife campus. And this is the road entrance. From top to down, it's from the main gate to the main campus. So this is just a picture of one of the flights, probably the 40th flight, on which it was carrying a GPS sensor for logging of some data. So I believe this is not the best it can be. Of course, you can always do better in life. There's no end to improvement. But we have to start from somewhere. As you all know, you've heard other speakers, drones have uses that continue to expand and they begin to be more efficient. Although it's dangerous because it can make people lose their employment. But we should not say no to development. Thank you very much.
Thank you, Peter. And so, after this time out, we are going on to fly the drone. So we will be using, I think the runway we have identified is the car park here. So in an orderly manner, we'll all go out, but please, the young ones, give the grandpas and the daddies at least that respect. Let them go out first, then you guys can come out afterwards. So drone guys. Yes, definitely, because by 5:20, we will then connect with the astronauts, and then you can ask questions. For those who are interested in asking questions, immediately after the drone flight.
This internet thing is what If you can just disconnect this one, now so move this one from the stand. Get it now. When you carry the camera, carry this lens,